Hello everyone, I'm Gökdeniz and I will start by introducing our project, and our project name is Better Self, and these are the team members. And project overview. What is Better Self? Better Self is a platform that you can realize for personal health and wellness tracking application, and it allows user to manage and track their daily habits and such as sleep, water intake, food and exercise. And you can see our motto in here: a healthier you, a better life. And with that, our project is supporting track progress and recover better. And you can monitor your personal test, sleep better, recover faster and easier. And for our project, the backend is built with Flask and the front end with built-in Angular. And we also use MySQL to store all the data with a properly designed relational scheme. And our features and modules. The platform includes several key modules: sleep tracker, water intake logger, food log, custom exercise program assigned by admins or user. Also, we have post system for sharing personal wellness updates. You can take notes or whatever you want. And we made sure that all modules are connected through a RESTful API, and every route is documented using Swagger UI for testing and transparency. And our goal was to build a full-feature wellness system that is secure, scalable, and easy to use. And Better Self helps users take control of their health routine with just a few clicks. And these are the photos of our webpage. That's all.
Hello sir, I am Mustafa. I will be presenting the requirements and our database structure. First, let's talk about the software requirement specification, the SRS. We divide them into three categories: business requirements, functional requirements, and non-functional requirements. Business requirements is the goal was to provide a complete wellness tracking system that works in a user-friendly and in a reliable way. The functional requirements include user registration, login, tracking of sleep and water intake, login food, viewing post, and assigning exercise programs. Non-functional requirements is actually we focused on a system performance, data security using JWT token, and availability using railway deployment. We also specified interface requirements such as RESTful APIs with JSON and a responsive UI using Angular. Performance wise, the backend responds in under 300 milliseconds, and we use caching to speed up speed up the external API calls. Now let's look at our database design. You may see here all of our tables, the properties of the tables and relations between them. For example, we have exercise table, water intake table, sleep records, and users tables. The relationship are enforced with foreign keys, and everything is normalized to avoid redundancy. The schema supports daily resets and consistent tracking of each user's health data.
Hello again. Now I will walk you through the technical structure of our project, including system architecture and deployment strategy. Let's start with the system architecture diagram. Our application follows a clean modular architecture. The Angular frontend communicates with the Flask backend API through secure HTTP requests. Each module in the backend, such as sleep, water, food, and admin, is separated using blueprints, which makes the codebase even more scalable and easier to maintain. The backend uses JWT authentication, meaning all users must provide a wallet token when accessing the protected routes. The food log feature uses OpenFoodFacts API since it's free and reachable. And to improve speed, we implemented a caching layer in the backend part. Now about deployment. Both front-end, backend, and also MySQL database deployed using Railway. It's a cloud hosting platform. The backend runs in a containerized environment, and the Angular frontend is served as static content. We use .env files to store sensitive information, and ensured HTTPS was used to secure all requests. Overall, our deployment is lightweight, fast, and reliable for real-time tracking. Thank you for listening my parts.
First of all, this is our landing page, and we have learn more button here. We have mockups we can see, and if we go down, and here we have about us section, and our team and contact us parts. If we go up, we can press get started. Let's log into admin account so we can see both admin and user account at the same time. And here's our profile page. We can edit our user by filling the form, and we can drink water, and we can enter a sleep duration like 5 hours, and we can also post some posts. Let's see, and for example we can delete it. Also we can delete the user, and then we can create some exercise programs. As we can see, we have a lot of exercises. We can just say example here. Also we can say example, and then it's created. After we create the example, we're gonna choose a date. For example, it's 5, and we're gonna assign it to that day. After that, here's overview. We can see our assigned exercise at that date, and then as we can see here, here's our progress. Here's our sleep quality, because my sleep preference is 9 hours, and we slept 5 hours for this day. And then let's add some nutrition data. For example, I'm gonna add some ketchup. Here, as we can see, we can edit this section. For example, 200 grams ketchup, it's gonna be 216 calories. And then we can add some maybe Doritos, and as we can see, we added Doritos. Also we can remove it, and at the overview section we can see it on the chart here, and also we can see at the cart here. So all the things are being usable from user. And here's also a section for admins. Admin can create an exercise like pull up, it's upper body, and it doesn't important. We can also add a URL of an image. We can submit it, and it's created. After that, we can edit a user from here. Also, we can delete a user from here.
Hi, I am Ömer. I will go over the challenges, risk management, and wrap up the presentation with a conclusion. During the development process, we face some common but critical risks. For example, sometimes the external food API was slow or unreachable. To handle this, we implemented caching and designed a fallback dataset. We also encountered authentication errors when JWT tokens expired. We solved this by adding proper token refresh and error handling. Other issues included front-end, back-end mismatches, and deployment bugs. We used tools like Swagger to ensure the API was always testable and consistent. Here is our table with detailed mitigation strategies. We planned proactively to make sure our system will remain stable. There is our table, there is risk IDs, descriptions, etc. To conclude, BetterSelf helped us to learn full stack development, real-world API integration, and team collaboration. In the future, we plan to add smart suggestions and mobile support. We also recorded a short demo video, which you can access through the link that we will attach in the file. Thank you for your attention.